In this video, we are going to do 16.01 has long string. All right. So I have the file downloaded and opened up in Racket. So let's just go over it and look for the problem statement. All right. Problem A. Notice that the data design steps are done above. All right. So all these steps are checked off. Let's just quickly review the data. List of string is one of empty. Our const string list of string, we are dealing with self-reference. And here is the template for that. Okay. Design the function has-long-string ? That consumes a list of string and produces true if and only if the list contains at least one string that is 9 or longer. And they give us some examples here. So const dog empty produces false, right? Because there's only one string here, and it's the list and it's the string dog. So it's only 3 long, right? But what about has long string of meow and butterfly, right? Butterfly is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 9 or longer, right? So this list const meow, const butterfly empty, right? This does have one string, at least one string, that is 9 or longer. So this should produce true, all right? Finish the uncompleted function steps 1 through 5 above. So these steps, as always. All right, so pause the video and try to work through this on your own. I'm going over spoilers in 3, 2, and 1. All right, I'm assuming that you took a good swing at it. So now let's go over it together. So signature has long string ? Consumes a list of string and produces a boolean. All right, purpose produces true if the given list has a string that is 9 or longer. Stub this out, so define has long string consumes a list of string. So string list is what I'm going to name the input variable, and produces a boolean, so we can do false as a dummy value. To run against some tests here, check expect has long string right? So we're going to do, what happens if we give it an empty, right? Well, it should produce false, all right? Check expect has long string of, let's do some examples of here. Let's just copy these down. Const dog empty, right? So there are no strings in this list that are 9 or longer, so this should produce false. All right, let's do this test, but with butterfly instead. Right, butterfly, and this would be true, right? Because there is one string that is 9 or more, and of course we can copy and paste this test up here. They gave us expect has long string this. Oh, whoops! I'll just paste that there. All right, so this also produces true. All right, and let's do one that's, smaller. Then it has none, but that's too long, right? Might as well. Has long string ? Cons dog cons cat empty. All right, so there are 2 strings in this list, and they're both not more than 9 long, right? So this should produce false. All right, we have a good set of tests, and hopefully this illustrates what the function will do. Let's run against the stub here. Get a lot of mismatches, it's fine. Let's comment out the stub. Look for some template that consumes a list of string that we can use as some scaffolding. Copy paste that down. Rename this. All right. So now really pause the video. Hopefully this should be all the mental scaffolding needed to solve the problem. I'm going over spoilers in 3, 2, and 1. All right, I'm assuming that you took a good swing at it. So now let's go over it together. So looking at our examples here, the base case, right, if we're given an empty list, we should just produce false. Okay, right, because there are no strings of 9 or longer in the empty list. All right, now for the hardest part, looking for the combinator and such. So since we're producing a boolean, we might look, might hint for us to look at, combinators for booleans. But again, we can deduce this by looking at what this list of string type is, right? We're consuming a list of string, and we have to determine whether it's 9 or longer. So when we determine things, we have to use booleans, right, to say whether they're true or false. So let's just, ask if this is 9 or longer, right? So this is going to be a string. So let's look at this test case. It's going to be the string dog, right? We want to test if the string dog is 9 or longer. So let's wrap this around a string length because we need how long is the string, right? And then we want to ask, is this, string length, is this greater than or equal to 9? Right, and this will produce a Boolean. All right, so we have to go look in the documentation, and you would, look at things to consume and produce Booleans. In this case, I know that we need an OR. So OR evaluates to true as soon as one of the expressions is true. That's kind of what we need, right? As soon as there's one string that's 9 or longer, right? We want to produce true, right? Like so. Okay, so we need an OR as the combinator here. What do we want to OR this against? Well, we want to OR this against, this recursive call to has long string, which we will assume will fulfill the purpose on the rest of the list. So let's run this code. And so all 5 tests do pass, right? And of course, let me just write one more test so I can explain something, right? Some of cons Lay's. I love those chips. All right. So, or, right? So as long as there's one string in here that's 9 or longer, right? We should also come up with a test that is like 10, right? 10 long. But I recommend you do that on your off time. All right. So these OR chains, right? It's going to do OR, whether these are 9 long. It's going to stop here actually, right? Because OR 4, right? This is 4 long. This is 9 long. It's not going to check lays, right? In fact, I recommend you, step through this case, do the stepper, and you'll realize that it's just going to stop here, and it's not going to do lays, right? Because we already found a string that's 9 or longer. It's butterfly. We don't gotta keep looking through the rest of the list, right? According to the purpose statement and what we want to stop immediately when there is a 9 or longer string, and that's what OR does. It's called short circuiting. All right. Anywho, let's just submit this in a hand-in test review and refactor. I'm gonna hit Control-I to re-indent. Everything looks pretty neat to me. I recommend you submit this to hand-in, check your score, make sure it passes the grader test, and etc. And also, as always, write this down in a table view so you can get a bird's eye view of each recursive call if you would like. Anywho, that's about it for this video, and I will catch you in the next one.